Okay, in this video we're going to learn how to solve a quadratic using completing the square. Anytime you want to use completing the square, we want to exhaust all other options when we can factorize a quadratic, because completing the square is quite difficult, so if there's an easier way to do it, we'd prefer to do it that way. So let's first look at this example here. X squared take 4x take 2. If we wanted to solve this quadratic, we can use the splitting the middle term technique, which states that we need to find two numbers that both add to negative 4 but then times to minus 2. Can you think of two integers, two positive or negative integers, that add to negative 4 and times to 2? Well, I certainly can't. So if I know I can't find two integers which satisfy this criteria, I'm going to start using splitting the middle term. Here is how splitting the middle term works. You need to assign each of the coefficients of the terms a letter. I'm going to say the coefficient of x squared is a, the coefficient of x is b, and just the constant is c. So it's in the form of y equals, well, in this case, 0 equals to ax squared plus bx plus c. So we have a quadratic that's in this form. The only value we're really interested in is the b term. So anytime you hear me say the b term, just look straight for the coefficient of x. And the coefficient of x in this case is minus 4. So here's how completing the square works. You're going to copy down the first two terms. X squared, take away 4x. Then, plus, in brackets, you take the b term. And the b term I said in this question was minus 4. So you do minus 4. And remember this very carefully. You take the b term. You halve it, then you square it. Okay, just remember that step there. You halve the b term, then you square the b term. And then I'm just going to copy down the minus 2. If that equals to 0, am I just allowed to randomly add this into an equation just because I felt like it? Well, definitely not. That's not how math works. If I add something, then I definitely have to take it away, correct? So that's exactly what I'm going to do. Rather than just adding the b term divided by 2, I'm also going to minus away the b term on 2. So we're also going to do minus 4 divided by 2 whole squared. And what's really special about completing the square is the first three terms. If we look at the first three terms in this equation here, we can factorize these first three terms as a perfect square. We can factorize it as ax plus b whole squared, something in this form. And the way we work out what these two terms are is we simply look at the terms that are inside of these in this orange rectangle. So inside this orange rectangle, we can see two terms with a square. We can see x squared, and we can see minus 4 on 2 whole squared. But the only thing I'm really interested in is the thing that's actually being squared. In this case, the x is being squared, and the minus 4 on 2 is being squared. And in this case, we're going to say minus 4 on 2 is simply equal to minus 2. So those are the two values that go in our brackets. So inside of our big brackets, we can say that it's x minus 2 whole squared. And that's how you can factorize what's in this orange box. Then we can just simply simplify the remaining constants. So we have minus 2 minus, and in this case we have minus 4 on 2, which is simply minus 2 whole squared. And that is the same as just 4. So we're really minusing away 4. Minus away 4 equals to 0. We can then simplify this to say x minus 2 whole squared minus 6 equals to 0, in which case x minus 2 whole squared is equal to 6. Now what we want to do is we want to isolate this equation for x take 2. We want to isolate for x take 2, then we want to isolate for x. And the first thing we're going to do is we're going to first get rid of the square. The opposite function of squaring something is the square root of something. So to both sides, I'm simply going to take the square root. And if I do this, what I'll end up having is I'll have x take 2 on the left-hand side, and on the right-hand side, I'll have the square root of 6. More specifically, we will have plus or minus square root 6. And the reason we have plus or minus square root 6 is think of it like this. What is the square root of 9? You would say that's 4. Sorry, you would say that's 3. And what's the square root of 16? You would say that's 4. And the square root of 25 is 5, etc., etc. So if the square root of 9 is 3, that means 3 times 3 equals 9. And if the square root of 16 is 4, that means 4 times 4 equals 16. But for this first example here, does negative 3 times negative 3 equal to 9 as well? And what about this example here? Doesn't negative 4 times negative 4 also equal to 16? So you're telling me that the square root of 16 is not only positive 4, but it's also negative 4. And you're telling me the square root of 9 is not only positive 3, but it's also negative 3. So that's why when we take the square root in completing the square, we must take both the positive and the negative examples. So let's continue. Now to solve this, I'm simply just going to add 2 to both sides. And in the process, I get x is the same as 2 plus or minus the square root of 6. So the two solutions I have is 2 plus the square root of 6, and then 2 minus the square root of 6. And that's how you solve this first equation using completing the square. Let's go through a few more example problems. The next one we're going to be doing is x squared minus 5x plus 2 equals to 0. Go ahead and give this example a go. Okay, so the first thing we need to recognize is this is in the form of ax squared plus bx plus c equals to 0. And the only term we're interested in is the coefficient of x. What is the value of b? For this function here, the equation of b is simply minus 5. So let's follow the exact same steps that we did in the previous example. We can say that x squared, take 5x is our first two terms, plus we take the b term, in this case the b term is minus 5, we halve it and then square it. And then we do plus 2. But again, we can't just randomly add this term in just because we felt like it. So I'm also going to do minus 5 on 2 whole squared. The first three terms, you can simplify it by looking at the terms that are inside the square. So x is being squared and minus 5 on 2 is being squared. So we can say this simplifies to x take 5 on 2 whole squared. Then we can simplify the remaining two terms. We can say it's plus 2 and minus 5 on 2 whole squared is the same as minus 25 on 4. And now we just want to simplify. So x take 5 over 2 whole squared, plus we can simplify this as 8 on 4 minus 25 on 4. And if we merge this as one fraction, 8 minus 25 is the same as minus 13. Oh, sorry, it's the same as minus 17. So we can say it's minus 17 on 4. Okay, now what we can do is move the 17 on 4 to the other side. So we get x take 5 on 2 whole squared equals to 17 on 4. And we can just square root both sides. So if we square root both sides, we can do x take 5 on 2 is the same as plus or minus the square root of 17 on 4. Hence, x is simply equal if we add 5 on 2 to both sides. Okay, because we want to cancel it out. We add 5 on 2 to both sides. That becomes 5 on 2 plus or minus the square root of 17 on 4. And that would be your answer, but we can simplify this. If I wanted to simplify, what I can rewrite this as is I can say the square root of a fraction, the square root of a over b, well, that's simply the same as the square root of a divided by the square root of b. So in looking at this question, the square root of 17 over 4, that's simply the same as the square root of 17 divided by the square root of 4. And what's the square root of 4? That's just 2. So if you wanted to simplify, we can say 5 on 2 plus or minus the square root of 17 all over 2. And we can recognize that we have a fraction and another fraction added together with the same denominator. So we can simplify this as 5 plus or minus the square root of 17 divided by 2. So 5 plus square root of 17 on 2 and 5 minus the square root of 17 over 2. Those would be your two solutions for this quadratic here. Let's keep moving. Let's keep working on a few more. The next one we're going to have a look at is 2x squared minus 4x plus 1 equals to 0. So in this question, if I ask you, what is the b term? You would say the b term is minus 4. Except, hold on a second, if we look at this question here, we have to be very careful. When you do completing the square, you must only do it with monic quadratics. And what does monic mean? A monic quadratic is a quadratic where the a term is 1. So if we have a quadratic that's 0 equals to ax squared plus bx plus c, we need the value of a to be equal to 1. It cannot be any other number, not -1, not 2, not 3, not any other number. In this case, we have it equal to 2. So hold on a minute, we have a non-monic quadratic. How do we make it monic? Well, you can just divide both sides of the equation by the leading coefficient. So if I were to do that, you can divide this side by 2, divide this side by 2. So what you end up with is you have x squared minus 2x plus a half equals to 0. So now let's carry on. If we wanted to solve this quadratic using completing the square, we now need to recognize the b term is actually -2. So in solving this, we can copy the first two terms. Then we can add in brackets the b term, halve it and then square it. Then we can copy out the last term, but we can't just add this in, so we also have to minus it away. Okay, so how can we simplify these first three terms here? It's simply by looking at the terms under the square. So this just simplifies as x minus 2 on 2 whole squared. And 2 on 2 is just 1, so I'm going to write x take 1 whole squared. Plus a half minus, well, this is the same as -1 whole squared. And we know -1 whole squared is just 1. So we're minusing away 1. And what's a half take a 1? A half take 1 is simply minus a half. So this is your equation here we're trying to solve now. So let's carry on. We have x take 1 whole squared is equal to positive a half. If we square root both sides, we can say x take 1 is the same as plus or minus the square root of 1 over 2. That means that x is simply 1 plus or minus the square root of 1 over 2. However, we do want to simplify this, and the way we simplify is by rationalizing. We can rewrite this third as the square root of 1 divided by the square root of 2. The square root of 1, that's simply just 1, but the square root of 2 cannot be simplified. So I'm going to rewrite this third as 1 divided by the square root of 2. To rationalize this, we can just times the numerator and the denominator by the square root of 2. So in that case, the numerator will simply equal to square root of 2, and the denominator will equal to 2. So x is now equal to 1 plus or minus square root of 2 over 2. And if we want to even further simplify it as just one fraction, we can rewrite 1 as 2 over 2. So now it's 2 over 2 plus or minus the square root of 2 over 2. And that just simplifies to 2 plus or minus the square root of 2 all over 2. Fantastic. That is your equation answer for x. Let's look at one last example. We're going to try and solve this equation here. Pause this video and give it a go. Okay, this is a 5, by the way, for those of you that misunderstood. So in order to solve this, we need to make it a monic quadratic. And the way we make it monic is divide the entire quadratic by your leading coefficient. And the leading coefficient in this case is just 3. So what we can say is 0 is the same as x squared minus 5 on 3x minus 2 over 3. Now what is the b term? The b term is minus 5 over 3. So now let's use completing the square. 0 is the same as x squared take 5 on 3x, that's me copying down the first three terms, plus, in brackets, minus 5 on 3 divided by 2, so half and then square. Another way of saying this is simply minus 5 on 6. Okay, then we can do minus 2 on 3, and obviously we can't just add this in just because we felt like it, so we're also going to minus it away. So minus 5 on 6 whole squared. Now the first three terms, you can factorize it as x minus 5 on 6 whole squared. And then we can do minus 2 over 3 and then minus 25 over 36. Because this squared is the same as minus 5 on 6 times minus 5 on 6. Numerator becomes 25, denominator becomes 36. Now, if we want to simplify this fraction, we can make the bases the same for both these fractions. So I'm just going to times the top by 12 and the bottom by 12. So 2 times 12 is 24, and 3 times 12 is 36. So we're really doing minus 24 on 36, minus away 25 on 36. What that gets us is minus 49 on 36. So 0 equals to x take 5 on 6 whole squared minus 49 over 36. Now we can keep going. We can equal 49 over 36 to be the same as x minus 5 on 6 whole squared. Now let's look at this. We need to square root both sides. What is the square root of 49 over 36? Well, that's the same as the square root of 49 divided by the square root of 36. And the square root of 49 is 7, square root of 36 is 6. There we go, 7 over 6. So plus or minus 7 over 6 is the same as x minus 5 on 6. That simply means that x is equal to 5 over 6 plus or minus 7 over 6. So what is this equal to? We can see that 5 plus 7 is 12 divided by 6. That means one of our solutions is just 2. And then if we do 5 minus 7, we can say that 5 minus 7 is just minus 2. And minus 2 divided by 6, so that's just minus a third. So that means the other solution is minus a third. And this is why I said at the very start, let's check, before we even do completing the square, whether or not the quadratic has very nice factorizable terms. If you did my video on completing the square, splitting the middle term, apologies, you would recognize to factorize a non-monic quadratic, we need to find two numbers that both add to minus 5, but then times to minus 6. Can you think of two numbers? Well, I can. I can think of the two numbers of minus 3. I can think of the numbers minus 6 and 1. Okay, those both will add to minus 5, but then times to minus 6. So we can simply factorize this by going 3x in one bracket, x in the other, and then we can say plus 1 in here, and then minus 2 in this bracket, because that's the only way we can get minus 2 by doing 1 times minus 2. And if we wanted to equal this to 0, we can use the null factor rule. The null factor rule says that 3x plus 1 must be equal to 0, in which case x equals to minus a third, or x minus 2 equals to 0, in which case x equals to 2. So we got the exact same solution for the fraction of the working out. So be very careful when you do completing the square. Always check if there's another way to solve it first.